सभी लोग जुड़ गए हैं। मेरे पास सभी का मैसेज आ गया।
दिख रहे जुड़ रहे हैं।
मैडम फेसबुक पेज लाइव कर दिया है मैंने।
अच्छा ठीक है।
हो गया है और लाइव।
मिनिमाइज हो गया, देखते हैं कहाँ से हो गया। मैं नहीं दिख रही फोटो में, ये छोटा हो गया। ये हटाना था ना लिस्ट, ये लिस्ट हटाना था। तीन मिनट बचे हैं और बोल दे प्रिंसिपल सर को लगा दे, ज्वाइन होने बोल दे। शिव
हाँ मैडम बस और रुक जाइए। हम लगा दीजिए फोन, लगा दीजिए।
दिव्या
लगा दो। दिव्या अनम्यूट।
दिव्या अनम्यूट है क्या?
हाँ दिव्या को अब
को होस्ट है ना वो?
हाँ दिव्या को शिव कर दो। शिव दिव्या को करो, उसका आवाज नहीं आ रही।
वो उसको को होस्ट बनाने को बोल दो मैडम।
शिव को आवाज जा रही है आपकी? हेलो हेलो शिव।
दिव्या का सरनेम क्या है?
दिव्या त्रिवेदी।
त्रिवेदी।
ठीक है, वो कर सकती है अपने आप को अपने लेवल पर।
हाँ। और सुरभि घोड़की वो भी बन गई क्या को होस्ट?
मतलब सभी को बनाना जरूरी क्या? सभी बोलेंगे क्या?
नहीं
वो
दो ही
सिर्फ दो
बोलेंगे।
लोग हाँ वो
जो
बोलना
बोलेंगे और उन्हीं को बनवाओ।
हाँ
जो
बस वो
बोलेंगे
उन्हीं को बोल रही हूँ मैं, वो
उन्हीं को।
बोलेंगी इसलिए उनको बनना दीजिए को होस्ट।
जो बोलेंगे उन्हीं को, बाकी सबको
हाँ।
बनाने का मतलब नहीं।
नहीं नहीं दो को। चलिए
दिव्या त्रिवेदी और सुरभि घोड़की।
जी
सर को लगा दूं फोन कि ज्वाइन हो जाए?
हाँ लगा दीजिए, सर को फोन लगा दीजिए मैडम।
जी सर ज्वाइन हो जाइए। जी सर हो रहे हैं सर ज्वाइन।
हाँ सर हो रहा है ज्वाइन, है ना? ठीक।
सुरभि को भी बना दिया ना शिव आपने को होस्ट, सुरभि घोटकी
नहीं बनाया उसको मैंने,
उसको भी
अभी
बना
प्राचार्य
देना।
सर जुड़ जा।
हाँ
बना
फिर
दे।
बस उसको एक को बना देना, तो मैडम तो फिर स्पीकर मैडम तो रहेंगी।
बस सर अब जुड़ने वाले हैं ना।
हाँ चलो दिख रहा है ना, हाँ, ठीक है।
जी, आपने अपना वीडियो ऑफ कर रखा है मैडम?
मैंने कर रखा ऑफ, करूँ कि चालू?
नहीं नहीं, अब रहने दीजिए, अभी रहने दीजिए।
सर आ जाए वैसे चालू करती हूँ, है ना?
हाँ, सिलावट सर आ गए हैं।
हाँ बस जब चालू कर दिया मैंने।
हाँ। सर जुड़ गए हैं मैडम, प्लीज।
हाँ
रश्मि मैडम।
हाँ
दिव्या,
हाँ आ गए सर।
हाँ सर आ गए।
नमस्कार
सर
सर।
नमस्कार।
नमस्कार नमस्कार।
सर नमस्कार, प्रणाम सर।
मैडम दिव्या को कह दीजिए स्टार्ट करने को।
हाँ दिव्या स्टार्ट करो।
Okay, ma'am. Hello and good afternoon, everyone. I, Divya Trivedi, extend a heartily welcome to all of you on behalf of Department of Statistics, Government Holkar Science College. I want to thank you all for taking your precious time out and being here today. I take this privilege to warmly welcome our honorable speaker, Dr. Snigdha Banerjee, ma'am, from School of Statistics, Devi Ahilya Vishwavidyalaya, Indore, all the participants from different states and countries. Also, I would like to welcome our honorable principal, sir, without whom it was not possible to get this program done. Now, I welcome heads of all the departments, all the professors, Professor Mangala Choragade ma'am, Head Department of Statistics, Program Coordinator Dr. Netram Kaurav sir, Head Department of Electronics, Professor Shivlal Mewada sir from Department of Computer Science, Organizing Secretary Dr. Rashmi Awad ma'am, and all my team members on first day of webinar on concept and applications of statistical methods in research. As we all know the importance of statistics in our routine life, the field of statistics is the science of learning from data. Statistics is a crucial process behind how we make discoveries in science, how we make decisions based on data, and how we make predictions. In this time of COVID-19 pandemic, everybody in our society is eager to know the latest news about number of newly infected persons, recovery rate, death rate, and how many cases India could be grappling within the next few months. The answer to all these questions is provided by ICMR, and WHO is based on statistical analysis. The doctors also test effectiveness of a drug in medical field with the help of statistical data. In the field of research, statistics plays a vital role. The role of statistics in research is to function as a tool in designing research, collecting data, analyzing it, and testing hypotheses. It explains and interprets the data and draws conclusion therefrom. Along with this, there are several fields of statistical applications like biostatistics, which is a branch of biology that studies biological phenomena and observations by means of statistical analysis and includes medical statistics. Then there is econometrics, which is a branch of economics that applies statistical methods of economics that applies to the empirical study of economic theories and causal relationships. Besides this, there is a business analytics, which is rapidly developing business process that applies statistical method to develop new insight to business performance and future opportunities. Apart from this, there are a lot of fields which require statistical application. In today's webinar, we will be knowing much more about statistical applications. So, moving forward to the webinar, I would like to invite Professor Mangala Choragade ma'am to welcome our honorable guest and tell everyone the outline of today's webinar. Thank you.
थैंक यू। सभी को नमस्कार और आज अंतर्राष्ट्रीय विश्व योग दिवस की भी शुभकामनाएं। मैं प्रोफेसर मंगला चोरागड़े, विभागाध्यक्ष सांख्यिकी, होलकर साइंस कॉलेज इंदौर, इस 2 दिवसीय वेबिनार में उपस्थित सभी विभागाध्यक्षों, प्रशासनिक अधिकारी, डॉक्टर आरसी दीक्षित सर, हमारे वेबिनार के प्रोग्राम कोऑर्डिनेटर डॉक्टर नेत्राम कौरव एवं शिवलाल मेवाड़ा, ऑर्गेनाइजेशन सेक्रेटरी डॉक्टर रश्मि अवार्ड एवं ऑर्गेनाइजेशन कमेटी के मेंबर्स, समस्त प्राध्यापक गण, विद्यार्थी एवं प्रतिभागियों का हार्दिक स्वागत एवं अभिनंदन करती हूँ। आज के वेबिनार के स्पीकर डॉक्टर स्निग्धा बनर्जी, प्रोफेसर देवी अहिल्या विश्वविद्यालय इंदौर से हैं। मैं उनका भी हार्दिक स्वागत अभिनंदन करती हूँ। उन्होंने हमें बहुत कम समय में हमारे निवेदन को स्वीकार कर अपनी सहमति प्रदान की। अब मैं हमारे महाविद्यालय के ऊर्जावान, कुशल नेतृत्व वाले प्राचार्य डॉक्टर सुरेश टी सिलावट सर का भी हार्दिक स्वागत व अभिनंदन करती हूँ। सर के बारे में मैं क्या कहूँ, बड़ी सोच, दूरदृष्टि, सकारात्मक ऊर्जा, हमारे सम्माननीय प्राचार्य होलकर विज्ञान महाविद्यालय एवं अतिरिक्त संचालक उच्च शिक्षा इंदौर संभाग के बारे में कहने के लिए मेरे पास शब्द नहीं है। यहाँ सुचिता, यहाँ अनुशासन, यहाँ प्रतिबद्धता दुर्लभ है। एक हाथ में सरलता की धरा, दूजे में विद्वता का नम है। हम सभी सौभाग्यशाली हैं आप जैसे प्राचार्य को पाकर। आपकी कार्य करने की शैली सर एकदम अनोखी है। आप बहुत ही अच्छे प्रबंधक हैं। आपका मैनेजमेंट देखते ही बनता है। आप हर किसी की समस्या को बहुत जल्दी समझकर उसका त्वरित निराकरण करते हैं। ऐसे हमारे मृदुभाषी प्राचार्य हैं। मैं हमारे प्राचार्य को यह बताना चाहती हूँ कि इस वेबिनार में देश विदेश से कुल 1775 लोग जुड़ चुके हैं, जिसमें से 450 के करीब फैकल्टीज, 550 के करीब स्टूडेंट और रिसर्चर्स और 150 के करीब भी अनेक देशों से लोग जुड़े हैं, जैसे घाना, नाइजीरिया, इंडोनेशिया, अफ्रीका, फिलीपींस, मलेशिया इत्यादि। इस वेबिनार का मुख्य उद्देश्य है कि वर्तमान में कोविड-19 के रिजल्ट की एनालिसिस करने में सांख्यिकी बहुत महत्वपूर्ण भूमिका निभा रहा है। मैं आदरणीय हमारे वेबिनार के पेट्रॉन डॉक्टर सुरेश टी सिलावट सर से अनुरोध करती हूँ कि वे सांख्यिकी विभाग द्वारा आयोजित 2 दिवसीय वेबिनार को शुभारंभ करने की अनुमति व आशीर्वचन प्रदान करें। डॉक्टर सुरेश टी सिलावट।
धन्यवाद मैडम मंगला चोरागड़े जी एवं सांख्यिकी विभाग एवं समस्त प्राध्यापक गण एवं प्रतिभागी सबको आज योगा दिवस की शुभकामनाएं। आपको बहुत बहुत नमस्कार साथियों। मैं डॉक्टर सुरेश सिलावट, अतिरिक्त संचालक उच्च शिक्षा इंदौर संभाग एवं प्रिंसिपल होलकर साइंस कॉलेज इंदौर, सांख्यिकी विभाग द्वारा आयोजित 2 दिवसीय वेबिनार कंसेप्ट एंड एप्लीकेशन ऑफ स्टैटिस्टिकल मेथड्स इन रिसर्च में उपस्थित सभी प्रतिभागियों का हार्दिक स्वागत व अभिनंदन करता हूं और विभाग की विभागाध्यक्ष डॉक्टर मंगला चोरागड़े एवं उनकी पूरी टीम को वेबिनार के आयोजन के लिए बधाइयां देता हूं और इसके लिए आईटी इंचार्ज नेत्राम कौरव, शिवलाल मेवाड़ा एवं प्रशासनिक अधिकारी आरसी दीक्षित जी को, साथ ही आज के इस वेबिनार के गेस्ट स्पीकर डॉक्टर स्निग्धा बनर्जी, प्रोफेसर डीएवीवी इंदौर तथा 22 तारीख के स्पीकर डॉक्टर राजेश टेलर, रीडर विक्रम विश्वविद्यालय उज्जैन का भी स्वागत व हार्दिक अभिनंदन करता हूं। इस वेबिनार में देश विदेश से जुड़े 1000 से ज्यादा प्रतिभागियों का स्वागत करता हूं। मुझे प्रसन्नता है कि इस वेबिनार में अधिक से अधिक संख्या में प्रतिभागियों का जुड़ना इस बात का सबूत है कि कोविड महामारी के दौर में भी विद्यार्थीगण, रिसर्च एवं प्राध्यापक अपने ज्ञान को बढ़ाने के लिए तत्पर हैं। आज के दौर में सांख्यिकी का महत्व प्रत्येक क्षेत्र में बढ़ता ही जा रहा है। सांख्यिकी विज्ञान की वह प्रणाली है जिसका प्रयोग प्राप्त आंकड़ों के विश्लेषण, एनालिसिस करने से किया जाता है। किसी भी क्षेत्र की पीएचडी थीसिस बिना सांख्यिकी के विश्लेषण से अधूरी मानी जाती है। कोविड-19 के बारे में जितनी भी जानकारी प्राप्त हो रही है वह सांख्यिकी एनालिसिस से ही हो रही है। मैं संस्था प्रमुख होने के नाते इस वेबिनार की विधिवत शुभारंभ करने की घोषणा करता हूं और एक बार फिर से सभी प्रतिभागियों का इस वेबिनार में स्वागत करता हूं और आशा करता हूं कि आप सभी वेबिनार से कुछ ना कुछ सीख कर ही जाएंगे। साथियों, आप सबका हार्दिक अभिनंदन, धन्यवाद, जय हिंद।
नमस्कार सर। दिव्या।
Now I would like, thank you sir for your words. Now I would like to invite Dr. Rashmi Awad ma'am for introducing our today's honorable speaker, Dr. Snigdha Banerjee ma'am.
Thank you, Divya. Good afternoon, one and all present here. It is a great honor for me to introduce and welcome our eminent speaker, Dr. Snigdha Banerjee of today's session, who is alumni of our college too. She did her graduation from Government Holkar Science College and post-graduation from DAVV Indore in the subject statistics. She did her PhD from Karnataka University, Dharwad, under the guidance of renowned statistician Professor B.R. Bhatt. She started her career from School of Statistics, DAVV Indore, as a teacher of statistics. She remained head of the department from 2004 to 2013. Under her headship, she organized several workshops, seminars, many invited talks time to time. She has made a powerful contribution in the field of research. She has published more than 55 research papers in various journals of international repute. She has published a book with a New Age publisher on MS Word 2000, which has found wide readership across the globe. Under her supervision, 7 students obtained their MPhil degree and 5 students awarded PhD degree and 2 are ongoing. She has guided more than 100 MSc projects in various areas of statistics. She is reviewer of around 15 international journals and she has delivered many plenary and invited talks and chaired sessions at many national and international conferences and workshops. Apart from her research work, she also provides consultancy service to many financial companies. Along with her team, she has developed a software package for a central government factory under the Ministry of Finance and provided consultancy service to national level finance companies. She is recipient of several academic awards for her research and teaching work. She was conferred with MP Young Scientist Award in the year 1990. She was honored with Gaurav Patra at Rajya Stariya Shikshavid Samman Samaroh in the year 2012 and presented the Research Appreciation Award by DAVV in 2017. Recently, she got AIAP Excellence Award by the Association of Inventory Academicians and Practitioners at International Conference held at University of Delhi. She is life member of many reputed academic bodies, societies like Indian Society for Probability and Statistics, Operations Research Society of India, International Science Communication Association, Association of Inventory Academicians and Practitioners, and many more. Her current research interest is in inventory models, supply chain analysis, and optimization with technique including genetic algorithm. Madam, your contribution in the field of education and research is very vast. It is very difficult task to present your work in such a short time, but I tried my best to do so. Today, we are privileged to have an opportunity to listen such a distinguished personality. On behalf of all gathered here, I welcome you, madam, and request you to deliver your lecture. Thank you. Madam.
Yes. Yeah. Thank you, Rashmi.
Thank you.
I thank the organizing committee of this webinar, especially Principal Dr. Silawat, Madam Mangala Chauragade, and Dr. Rashmi Awad for having given this opportunity to me to share the platform with the international fraternity. Right. So in this webinar, we have a series of two talks, and the first one is by me. Basically, a lot has been said by Madam Divya Trivedi about the applications of statistics in various fields. So I think I do not need to repeat it. Researchers all around the world know the importance of statistics. Within this one short hour, I'll be trying to concentrate more on just a few topics. But I've been to various workshops and conferences, etc., where I had to explain the tests of statistical hypothesis. I found, or rather inference, I found that it was very evident that people are afraid of statistics, and they just keep fumbling, most of them, not all, from other fields. They keep fumbling about what to do in research, how to go about it. So what I've tried to do is I've tried to concentrate on one topic, that is tests of statistical hypothesis and the concepts of that. And the basic concept is sampling distributions. So I chose this for my research, for my presentation today. I hope this will be useful for you. Okay, so when we do research, anyone who is doing research, especially outside the laboratory in the real world, they are interested in collecting data, analyzing, interpreting, as Dr. Silawat said, as Madam Chauragade said, as Divya Trivedi said. So definitely you have to collect data and extract information from the data. That is the basic idea of collecting the data. At present, all of us are in this webinar because of the COVID pandemic. And this COVID pandemic has, on one hand, given some negative side to the studies and academics and research, whereas for COVID, a lot of research is being done in terms of medicine, in terms of precautionary measures, in terms of the prediction of the number of persons being affected, being treated, etc. So since COVID is dominating this whole world right now, I'm beginning this unique conference with participants from all over the world, whom I welcome to this session, by a news of 16th June 2020, and that is that a team from Oxford University, team led by Oxford University, they have discovered a medicine, dexamethasone, which they say is the first life-saving drug. In the trial, they considered more than 6,000 patients, 2,000 of whom were given dexamethasone, and 4,000 plus were not given dexamethasone, and the results were compared. They found that reduction in death risk of high-risk patients. So let's take it word by word. They're taking high-risk patients. That means they're talking only about patients who are almost, in some terms, close to death or who need very good care, those who are on ventilator or on oxygen. So their risk reduction especially is for this set of high-risk patients. The reduction in death risk of those on ventilator was reduced by 1/3, and those on oxygen was reduced by 1/5 due to dexamethasone. This is what they are claiming, and their claim is supported by the research using data of 6,000 plus patients. Those of you who are interested in the report, they can go to this website, which I'm giving here. This is www.bbc.com/news/health5306121. The same research has presented in using what we call using this result. This is very easy to comprehend. That is, out of 8 patients on ventilator, 1 life is saved for every 8 treated, and for those patients on oxygen, 1 life is saved for every 25. Now, both of these slides which I've presented till now, they show us the major contribution, the major parts of statistics. One, the earlier one which I showed, shows, and plus this one. The question is, are we interested in those 6,000 plus patients who have been considered in this particular trial, in this particular experiment? No, we are not. We are interested in not just this sample result, because those persons are not the persons from your country or my country or whatever. Doctors are interested in them, they themselves are interested, we are also interested, but we are interested in not only those patients, we are interested in finding whether dexamethasone is life-saving drug, proves as a life-saving drug for the entire population of COVID affected persons. So this is the basic 2 roles of statistics. One is descriptive statistics, which was the second slide where we showed through pictures, where they showed through pictures how many persons are infected, how many treated, which was very easy for us to understand. And this descriptive statistics enables us to intelligently and rationally collect the data, summarize the findings of the data, and present the collected data in terms of tables, graphs, pictures, etc. The other and major contribution of statistics is what I showed at the end, that is sample data to population decisions. That is what statistical inference does. We use a sample to infer about the population, and this itself has 2 major parts, of which we would be considering test of statistical hypothesis in this short span. Now, I have a pillar here. What is this pillar? This pillar is the pillar of sampling distribution, which is carrying the weight of the entire statistical inference. Statistical inference is basically based on the concept and applications of sampling distributions. So once you understand the basics of sampling distribution, I suppose you would be able to understand the what and the how of tests of statistical hypothesis. So let's go ahead with this pillar, which is carrying the statistical inference on its shoulders. Before going further, I've used the word population, I've used the word sample, I've used, and commonly we use the word random sample. And so what are these? I put a question mark here before population. This basically is to tell that the question is always regarding the population. We don't ask questions about the sample. We use the sample, but to talk about the population. So the question is always regarding the sample. To go slightly technical, when you write your hypothesis, the hypothesis should always be regarding the population, not regarding the sample. And what is a population? The population is the entire set of units. It could be guinea pigs, it could be human beings, it could be books, it could be sports, it could be whatever, but the entire set of units of interest in a particular study. Whatever the question is raised regarding whatever set of units, that set of units is the population. For example, if I say that from this group, I'm interested in studying the feedback of only the non-Indians, the persons from outside, because I'll be really interested to know how they like my talk. So then my population for that particular study would be the non-Indian participants. Otherwise, Actually, I'm interested in all the participants, in feedbacks of all the participants, and that becomes my population. So population is the set of units of interest to the researcher. Then we don't study the entire population. Why? Just because generally it's terribly expensive. Sometimes it is expensive in both in terms of money as well as time. And sometimes what should you say? Sometimes it becomes very difficult to, it becomes, let's say, impossible to take a sample, to test the entire population. Why? Supposing you're manufacturing bulbs and you say, I'll check all the bulbs before selling. I'll check them till they are exhausted, they're fused. Then what will you sell? There's nothing to sell, isn't it? Similarly, I often think about supposing I go to a doctor for a blood test and the doctor does not believe in a sample. He says, no, I'll extract all your blood. So in that case, I won't be there to get the results of my blood test. So sample sometimes is essential whenever the testing of the sample is destructive. And if the testing is not destructive, still you can use a sample in order to save money, save cost. Random sample. We always say take a random sample. Why do we say take a random sample? Unless you take a random sample, the validity of statistical results cannot be ensured. In order to have validity of statistical results, you must take a random sample. And what is a random sample? A random sample, of course, there are various types of random samples. In short, it's a method of sample selection which ensures that every sample of that size will have the same chance of being selected. That means I'm not being biased that I will take only such samples. Supposing you want to show that your medicine is effective for treating coronavirus patients. So you'll take the sample of only those who are very slightly ill and say, no, my medicine has cured all the persons. Such a thing is not allowed in statistics. You require a random sample for the validity of results. Otherwise, they will not be believable. Right. One thing which we have to use in statistical analysis is the sample statistic. A sample statistic is something very simple. It's any function of the sample observations. It could be the sample mean, the sample variance, sample median, range, call it what, whenever you use only the sample observations for calculating a function, that becomes a sample statistic. Now we also use a word test statistic. It is just a sample statistic which is being put to use for testing, that is for deciding whether or not to reject some claim that we are making. So test statistic is just a sample statistic. That means it's a function of the sample observation. Now we said that you have to take samples. Okay, we take a sample. Supposing we say that the average, supposing I know somebody has told me, suppose Professor Mangala Chouragade has told me that the heights of all the girl students studying at Holkar Science College is 5 feet 3 inches. Okay, I take her word for it. Now somebody says, how do you say that? They're not going to take my claim or madam's claim. They say, okay, we'll test. Okay, test. Now supposing they say we'll test using a sample of size 10. And not just one sample, we'll take 2 samples because we need some sort of corroboration. So, okay, one group took samples of 10 persons, that's the first sample. The average height there turns out to be not 5 feet 3 inches, it turns out to be 5 feet 5 inches. When the second sample was taken, the average height turns out to be 5 feet 1 inch. What is this? Neither the 2 sample means are equal, nor are they equal to the population mean. That is because we do not have the totality. There are some observations missing from which are there in the population but not in the sample. Hence, there is going to be a difference, and this is the critical part of inferential statistics. We have to determine how far sample statistics from different samples are likely to vary from each other and from the population parameter. This forms the crux of the entire test of statistical hypothesis. And this is somewhat like what I'm saying. Supposing this is the population mean, and if I take the sample means, they're going to vary up to this, they're going to vary up to this, far and wide. How far and wide? That depends upon the variability, which we call as the standard deviation. And the variability not of the population, we are interested in standard deviation of the sampling distribution, which has a nice fancy name called statistical standard error of the statistic. This is what we are interested in. So once again, sampling distribution comes into play. If the variation is large, then you can think that 5 feet 5 inches is a valid value from this population. Otherwise, we would say that it's very unlikely that 5 feet 5 inches is from this particular population having mean height 5 feet 3 inches. Must be from some other population. Why? Because this probability, this area is very small. This forms the basic crux, finding the sampling distribution and the probability under that. That gives you the p-value. That's the basic. I'll go to slight more detail. Right, sampling distribution of a sample statistic. This is basically about how sample statistics vary, how much sample statistics vary, and sampling distribution of commonly used. Of course, we have many more, but commonly used tests in research, especially outside statistics, especially the biological research and management, etc., is more or less restricted to T, Z, chi-square, and F. And we call it a t-test. If the sampling distribution is T, we call it the Z-test. We have another Z, but Z scores, normal test. If the sampling distribution is standard normal, otherwise chi-square test for categorical data, and so on. So basically, it depends upon the sampling distribution of the test statistic that gives the name to the test. All right, so let's see what is sampling distribution of a sample statistic. It's something very simple, which is the distribution of values of the statistic calculated from all possible samples. Not that simple. Okay, let me make it a little more simple. Suppose we have a population of a random variable y, and we draw all possible samples of some particular size n. And for each sample, we calculate the statistic value of the statistic s. Let's say we calculate sample mean from each of the samples. And then we draw the basic histogram frequency curve of the calculated values and the relative frequency distribution. Relative frequency is the frequency of the class divided by the total frequency. So this relative frequency would approximate what is called the sampling distribution of the mean for that particular sample size. Let me do it here for you. Here, I have a population 1, 2, 3, 4, 5, a very small population. I don't need to take a sample from that, but still just to illustrate, I have a population of 1, 2, 3, 4, 5, and that means my population size is 5. Population mean is 20 divided by 5, that is 4, and the population standard deviation is 1.141. Now, I'm taking all possible samples of size 2 here. That means it will start with replacement. So 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, then 3, 2, 3, 3, and so on and so forth. So like this, I have 25 samples. Now, for these 25 samples, the sample size is 2 and sample standard deviation, that means the standard error, is the population standard deviation divided by square root of the sample size. That turns out to be 1. Now, I'll do the same thing in another way. The mean of the 25 sample means. Now, I look at only this column and find the mean of these, and it turns out to be 4. And if I find the standard deviation of these as a population, not as the sample standard deviation, that also turns out to be 1. So this formula is what we have by taking the standard deviation of all of these. Now I go a step further. I now once again look at only this column, and from here I find that the mean 2 has occurred only once. It has frequency 1. Mean 2.5 is here and here. So 2.5 has occurred twice. 4 has occurred 1, 2, 3, 4, 5 times, and so on. So I have my frequency distribution as you usually do. And using this frequency distribution, I now draw a histogram. All of this can be very easily done in any software, that is Excel or SPSS or whatever. And using that, I've obtained this histogram. And this, of course, because it's a very small population, this gives me the sampling distribution. So from the mean, the possibility that from 4, I have deviation to 4.5 is very high, it's very close to the mean. But deviation to 6 has a lower probability. All right. So basically, this is what we have, the probability that you have this value so far from the stated mean or stated statistic value. So this is essentially what a sampling distribution is. You find all possible samples, you calculate the statistic from each of the samples, you find the standard deviation of this set, and you get the standard error, and you find the mean of this set, etc. Now let us go on to specific distributions, specific sampling distributions. My talk is essentially about sampling distribution of sample mean, about the tests regarding sample mean. So I'm interested in sampling distribution of sample mean. Suppose the population mean is mu and population variance is sigma square. I'm assuming that both of these exist. Then what will be the sampling distribution of sample mean? It will depend upon two things. Number one, whether the population variance is known or the population variance is unknown. And number two, whether the sample size is large or small. Suppose the parent population is normal. Normal is like how the figure I just showed, that is bell-shaped is the normal distribution, bell-shaped with certain properties. If the parent population is normal with variance known, then the sampling distribution of X bar will be, the sample mean would be normal with mean same as the population mean and standard error as population variance divided by n. Whatever be the sample size, provided the population has a normal distribution. Suppose the parent population is not known to be normal, is quite different from normal, not just a little different, quite different from normal, with finite means and finite non-zero variance. Then the sample mean would once again be normally distributed with mean mu and variance sigma square by n when the sample size is large. We say infinite, but in statistics, greater than equal to 30 is infinity, which mathematics people generally don't agree. And this is due to the famous central limit theorem that is famous in statistics. Okay, so I just go back to the last result. Whatever be the sample size, if you take sampling distribution of X bar, that means I take all possible X bars and obtain the histogram for that. What happens? Now this is the population. You can see this is far from bell shape. You have height here, it's more like a U-shaped population distribution. So this is highly non-normal. And then if I take samples of size n equal to 5, all possible samples of size n equal to 5, and form the histogram like we did just now, then I get this kind of a thing, much more symmetrical, very different from the original population, and not exactly symmetrical. You can see there's a positive skew here. But the variation earlier, this is mean plus minus 1 standard deviation. So standard deviation was somewhat like 8 here. Here, mean plus minus 1 standard deviation, the standard deviation is something like 4. So standard deviation has reduced. And now if I take sample mean of samples of size 25 from the same population, then I get a much smaller variance because you divide by the variance, right? For those who are who know a bit of statistics. So I get much smaller spread when I increase the sample size. And the interesting part is that all of this is having all the three, the population as well as the distribution with mean 5, as well as the with size 5, as well as the distribution of samples of size 25, all three have the same mean. So as I said, the mean will remain the same and standard error will depend upon the sample size. And this, of course, is from, let me tell you the source. This is from Sampling Distribution of the Mean by David M. Lane. You can find it on the internet. Now, when sigma is unknown, till now we've been assuming that sigma is known, then this is the distribution is normal. When sigma is unknown and as well as the sample size is small. If sample size is large, the distribution of the sample mean will be normal. If the sample size is smaller than 30, then the distribution will be T distribution with new degrees of freedom, which we call as T new distribution. And when this degrees of freedom goes to infinity, as I said, infinity in statistics most often is greater than 30, then the standard normal distribution can be used, or rather is used in place of the T distribution. So please remember, population variance unknown and the population variance unknown and sample size small, you have to use T distribution. If population variance is known, whatever be the sample size, you use the standard normal distribution or use the normal distribution or the standard normal Z score. Right. So let us go to the main topic, tests of hypothesis for research. I'll begin with the beginning. I've used 3 words. I've used hypothesis, I've used test, and then of course we said that every research begins with data. Every good research is data driven, and we try to extract information from the data. How do we do that? By analyzing and interpreting. But how do we do research? When do we do research? When we have some idea, some assertion that we are trying to prove to others, to prove to the world possibly. So a researcher's testable idea or claim or assumption or assertion regarding the population, as I said, the question is always regarding the population probability distribution, is called a statistical hypothesis. Had it been only an assertion, I would have called it a hypothesis. But when it is a statistical hypothesis, it has to be regarding the population probability distribution, maybe regarding the population parameters, constants of the population, we describe the population completely, or regarding the shape or whatever. But it has to be about the population. Next, who's going to believe my idea? If I say, for example, I'm not a pharmacist. In fact, the medicines for COVID have been really being researched into. We have so many homeopaths who are claiming that a combination of 5 medicines cures COVID very fast. We also have the Indian system called Ayurveda. They are also claiming that they are claiming with result, with evidence as data, that they can cure people. Of course, the classes taken have been different. Some are taking very high risk people, some are taking low risk people. At least for low risk people, the Ayurvedic and homeopathic treatments have been proved fruitful. And how did they do it? They collected data and they had to prove to the world. So they had to check the data or test the data, check or test the hypothesis using the data as evidence. It's like the court, the judge requires evidence to give his verdict. Similarly, the statistical tests require data as evidence. Data is to be collected from a representative sample, random sample, which we call, of the population. And the big question is, does the data support the claim or the hypothesis? If the data supports the claim, we will say, okay, the claim can be taken to be true. If the data does not support, then we say, no, we cannot say that the claim is true. Right. So we've been saying test, test, test. What is a test? It's nothing but a simple stepwise procedure to answer the question whether to accept or reject a hypothesis, which is based on concepts of probability and on the sample data. So what is the procedure? The procedure you can summarize in 6 steps, 6 basic steps. One is you have to state what are known as null hypothesis and the alternative hypothesis. Now this comes from your research. What is it that you want to show? In fact, in the disciplines which apply statistics, generally they call it as research hypothesis. The hypothesis which you want to prove, you call as prove, or rather you're interested in proving. You cannot prove, the data will prove or disprove, but you're interested in proving, you call it the research hypothesis. Now that hypothesis is what you call as the alternative hypothesis. We put that as an alternative hypothesis, and the complement of that we put as what is known as the null hypothesis. Once the null hypothesis is rejected, automatically the alternative hypothesis is accepted. And when or how do you reject or reject null hypothesis? We reject null hypothesis based on data and of course the following steps. So how do you put the hypothesis? This is one of the most common confusions in applied research. Always put your research hypothesis as the alternative hypothesis, because rejection of null hypothesis is a very strong statement. So if you reject the null hypothesis, your hypothesis which you want to prove becomes positive. That means it is affirmed that your hypothesis is true. So your research hypothesis is the alternative hypothesis, and the complement of that generally is the null hypothesis. One more thing about the null hypothesis is whenever you have an equality sign, might be less than equal to, greater than equal to, only equal to, parameter value equal to some value, that equality sign always comes in the null hypothesis. So don't put the equality sign in alternative hypothesis. This has a mathematical basis. We take that equality sign as the limit for, as the value for the null hypothesis when we find the sampling distribution, for those who are interested in slide details. The second one, see I put some stars here, these stars here and here and here. This shows that you require a knowledge of the sampling distribution of the test statistic. So the second step, once you've stated your null and alternative hypothesis, that means you're clear about what you want, what is the kind of research that you are, what is it that you want your research to prove or not. So you have to choose an appropriate statistical test based on your null and alternative hypothesis. Then you should know, when I say appropriate statistical test, that means I want a test statistic appropriate for testing the null hypothesis against this alternative hypothesis, and for which I know the sampling distribution. So all these 3 things come in this one small sentence. Then decide upon the desired, what we call as level of significance. That is how much error, what percentage of error are we permitting, are we able to tolerate when we reject the null hypothesis, we say no, it is not true, although it is true. So you have to decide upon how much error you are permitting tolerance of. After doing all this, you collect data from a sample. Rather, you collect a sample and then collect data for the sample, whatever. And then you compute the test statistic from the observations. So once you know the test statistic and its sampling distribution, of course, test statistic, you can calculate the test statistic. And next, you find what is known as the p-value. This is the new approach. Earlier, we used to have an approach of critical region, etc. And how do you find the p-value? Okay, I'll go to the next slide after this. And based on the p-value, you accept or reject the null hypothesis. Now, before going on further, I'd like to show you a picture. This is a picture, most of you must have read this fable when you were very small, maybe 5, 6, 7 years old. This is the picture of an elephant. We can all see because we have our eyes. We can see in the totality. But these 6 persons, they are blind. They want to know how an elephant looks, and they spread around and take, one holds the tail of the elephant and says it's like a thread. One holds the side and says an elephant is like a wall. One holds the tusk and says that it's like a spear, and so on. So they are having different views and they are having different conclusions, inferences regarding the elephant because they cannot see it. So broadly, this implies that one's subjective experience, which is actually our sample, can be true, but that such experience is inherently limited by its failure to account for the other truths or totality of the truth, which is the actual population. We want the truth, we do not know the truth. We are blind as far as our actual hypothesis is concerned. So population actually gives you the full view, sample gives you a limited view, and different samples may give different pictures and not the full information. This takes us to the basic, the statisticians are very familiar with this picture. There's a truth which we do not know, the elephant which the blind persons cannot see. We do not know what the truth is. We can only decide either to reject our null hypothesis or to not reject null hypothesis. That means accept it, or here we accept the alternative. And if we reject the null hypothesis whereas it's actually true, then we are committing an error. If we do not reject whereas it is false, then we commit another type of error, which we call as type 1 error. Probability of type 1 error is known as alpha, and 100 into type 1 error is called the level of significance. Confidence level is sometimes known as 1 minus alpha into 100. And for calculating the level of significance is 100 into 1 alpha. That is the percent of times we decide to reject H0 while H0 is true. And for calculating sample sizes, we require what is known as power of the test or probability of type 2 error, which we're not going to discuss in this talk. All right, so when to reject the null hypothesis, we consider the p-value approach. Here, we have an observed value of the statistic, which is calculated from the observations from the sample data. And for example, we said the sample mean had height, the sample mean was 5 feet 5 inches. And then from this observed value, we find the p-value, which is the chance of getting observed value or a more extreme value, provided the null hypothesis is true. What is a more extreme value? An extreme value which favors the alternative hypothesis. For example, if the average population height is 5 feet 3 inches, how likely, the probability p-value is, how likely is it that the sample mean is 5 feet 5 inches or more? If the p-value, if this chance turns out to be very small, we say that it is highly unlikely to get such a value, so the null hypothesis is not true. Because had it been true, it is highly unlikely that we get such a high value. If the p-value is very small, you reject, data does not support the null hypothesis, and the decision is to reject the null hypothesis. So reject the null hypothesis if p is less than equal to 0.05, we say that we reject H0 at 5% level of significance. Otherwise, less than 0.01, you reject at 1% level of significance. Right. So this is what I'm saying. This is where you put the null hypothesis. I said equality sign is put with in the null hypothesis. So value specified, stated by the null hypothesis we are putting here. 5 feet 5 inches. What is the chance of getting 5 feet 5 inches or more? It's the small area out of this total area of 1. So if it's a very small area, we say that if this is the true distribution, then it is highly unlikely that 5 feet 5 inches or higher would be the height of students in the sample. So we would reject the null hypothesis here when this is the sampling distribution of the sample mean. After the test is conducted, what? The real question is not whether the null hypothesis is correct or not, but can it be used as an approximation, and then this gives us the step, on the basis of this, we step forwards. And the result of a test begins the next part of the research survey. Do we need to take more observations? Do we need to search more or not? So I hope you realize that fundamental of test, as well as, of course, the entire statistical inference is sampling distribution. Now I think I'm nearing the end of my time. So I'll just consider Z test and T test for means. This is for quantitative data when you have either one sample or two samples related or independent, which parametric test is to be applied. The test for means Z test or T test. I hope you remember variance known or sample large, you use the Z test. Variance unknown as well as sample size small, you use T test for single sample, two independent samples or paired samples. And what is the condition for validity of these tests? The parent population must be normal. You don't get exactly normal in real life. It should be not far from normal. Okay, so let's take a Z test for single population. You have the population distribution normal, variance known, sample size large or small, whatever, because the population is normal. Null hypothesis H naught mu equal to mu H naught, and alternative hypothesis H1. Here the equality sign is with mu H naught. Alternative could be mu less than mu H naught, mu greater than mu H naught. These we call as the directional hypothesis, directional alternative. And in these two cases, we have what is known as a one-tailed test. Then it could be just not equal to, this is called a non-directional alternative. In this case, we use what is known as a two-tailed test. And the sample mean is X bar, let's say. In that case, the test statistic, that is, you need to calculate this from the sample. You compute the observed set from the sample. Sampling distribution of this test statistic is normal 0, 1, that is the Z statistic, and find the p-value. If the p-value is less than 0.05, what do? You reject the null hypothesis. Without examples, theory is never clear. So let us take the example of a principal at a school who claims that the students in his school are above average intelligence. They have above average intelligence. And what is average intelligence? Measured using IQ. I suppose it is 100. And suppose the population variance, standard deviation is 15. And a random, naturally, nobody will take his claim. So a random sample of 30 students, IQs of 30 students is taken, and they have a mean score of 112.5. Not so large, not so much larger than 112.5. What's it? Let's see. Let's try a statistical test. Okay, before this, what should be our null hypothesis? What does the principal want to show? He wants to show that his students have a higher intelligence level. So what should be the alternative hypothesis? That the mean level is greater than 100. This is what the principal wants to prove. And what should be the null hypothesis? The alternative, the complement of this, that is mu is less than equal to 100. If this is rejected, this is strongly accepted. Now, supposing we have these observed values. Oh no, the observed, sorry. Supposing the data, okay, we already given the mean. So we have the observed mean as 112.5 minus the mean which is specified by the null hypothesis, mu H naught. That is 100 divided by the population standard deviation divided by square root of the sample size 30. So this is what we get. This is the calculated or observed value of the statistic. And you can find you can apply any software. You can directly get this value. Supposing you apply the supposing you apply Excel, then you can find the probability that Z is greater than 4.56. Why did I say only greater? Because our alternative is one-sided, mu greater than 100. So if Z is greater than 4.56, what is this probability of the observed or more extreme value greater than 4.56? And you apply this simple command to Excel, you get the value as 0.000026, very much smaller than 0.01. So the decision would be, because P is less than 0.01, P value is less than 0.01, we reject H naught. We can say we just reject H naught, or we can say we reject H naught at 1% level of significance. And we should not stop at this. We should always conclude in terms of the language of the problem. So we have to say that the sample data supports the principal's claim that the students in his school have an IQ above average. Let's take up another example. You have a certain element U in the blood in parts per million with standard deviation of males as 14.1, females as 9.5. I'm not talking about the means. Random samples were taken of 75 males, 50 females, and the blood test sample mean of U per parts per million was for males 28 and for females it was 33. Now, the question which the researcher wants to find out is the population mean ppm of U same for males and females? And of course, he says that you can assume that the population distributions are normal with mean mu and with mean mu m and variance sigma m square, etc. for males and females. Now, once again, set up the null and alternative hypothesis. The researcher generally is interested in showing that these differ. So differ, he does not know the direction of difference. So he just says that mean for first, let's say this is for males and this is for females, is not equal to 0. And the null hypothesis would be, alternative is what the researcher is trying to prove. And the null hypothesis is its complement, that is, this is equal to 0 and alternative is not equal to 0. And we just calculate the values, which turns out to be minus 2.37. 3237. Okay. So sampling distribution of this statistic is normal 0, 1. You try to find probability Z is less than minus 2.37. In Excel, this is the command. My norm S. When I've found Z, normal 0, 1, I have to add an S here. Norms dist minus 2.37. And I get the p-value as 0.00 whatever 8894, which is much smaller than 0.01. So once again, reject H naught at 1% level of significance, and we conclude that the mean trace metal U in the blood of men and women are significantly different. Right. So I asked the organizers whether they'll allow me some more time for t-test. Am I allowed some more time or should I stop? Yeah, organizers, please.
Madam,
Can you speak a little more for maybe 5-10 minutes?
Okay, 5 minutes.
Or do you want to take questions around? Okay, let me start till the organizers are deciding. A city health department wishes to determine if some bacteria count per unit volume of water at a lake is within the safety level of 200. The municipal corporation, of course, is interested in showing that it is within that, because that is their interest. And a researcher collected 10 samples of unit volumes and found the bacteria count to be these values. Those who are from environment, etc., and biochemistry, whatever field, they would know the numbers better. Does this data indicate that the bacteria count is within the safety level? That is the municipal corporation doing its job or not? They are saying that one error out of 100 decisions is allowed. So measurements constitute a normal sample, this you can assume. And Right. So what would be the null hypothesis and alternative? We first start with the alternative. What does the municipal corporation want? That it is less than 200. So that is the alternative hypothesis. The null hypothesis is the complementary greater than or equal to 200. And we calculate the t value, and that turns out to be, the p value for this turns out to be 0.1214, which is greater than 0.05. And so we cannot reject the null hypothesis. We cannot conclude that the null hypothesis is not true. The data supports the null hypothesis. So the municipal corporation is not doing its work. It is, we cannot say that H1 is accepted. Right. And then we have the two independent samples test. Yeah, right. If you want to take any questions, you can take, or I'll just show this example. You have to test whether average, I'm taking now t-test for two independent samples. We wish to test whether average national test score, it could be GATE, whatever, is different of college A is different from that of college B. The variability in the two colleges is the same. This is one assumption we are making. If they are different, we have to use a different test. So once again, null hypothesis. One college wants to say that they are not the same. We are better.
मैडम को कंटिन्यू करना है कि क्या करना है?
हाँ, आप बता दीजिए. आप क्वेश्चंस लेना है तो ले लीजिए. ये लास्ट बता रहे हम. Because your time is almost at the end. So I'm just showing my slide. You may take your decision. So we have unknown variance here. The population variance is unknown. So the test to be applied is 2. The sample sizes are different and the two samples are independent. So we apply t-test for two independent samples. And if you go to Excel, you can apply these syntax: t-test, array 1, array 2, number of tails. Here we have a non-directional alternative. So there are two tests, and the type of test, because it is independent samples with same variances, you should write 2 for this. So 2 tails, type 2, and you have to select array 1 and array 2. And this is what you get after apply. You can apply the test wherever. So t value is turning out to be 1.4382, and the two-tailed p value is 0.1723, which is greater than 0.05. So what do? That I leave for the participants to tell me. Yeah, I think we can stop now.
Thank you, madam. Very knowledgeable.
Thanks to the participants. I hope it was useful, and I hope the foreign participants could understand my diction and pronunciation. I just forgot that they were also there, but I hope they could understand.
Thank you so much.
Thanks to all. Thanks to all the participants and the organizers once again.
Thank you. Thank you so much, ma'am, for your commendable talk on the subject. Now I would like to invite Surbi ma'am for giving vote of thanks.
क्वेश्चन आंसर सेशन के लिए
one minute. काफी पार्टिसिपेंट्स के क्या हैंड्स आ रहे हैं कि वो क्वेश्चन पूछना चाह रहे हैं. दीपक साहू, चालिका चोनिया.
मैडम अपना इसको ऑफ कर दीजिए आप.
I'm not getting those.
पीपीटी को.
Okay.
दीपक साहू को सर अनम्यूट कर दीजिए अगर वो क्वेश्चन पूछना चाह रहा है तो.
नहीं, आप मैं कर दूंगा. ठीक है.
हाँ.
मैं
Okay, so
दीपक साहू.
दीपक साहू आप अपने आप को अनम्यूट करें और पूछिए अपना सवाल.
Okay, no one.
Next.
चिलिका
चिनॉय.
Yes.
प्लीज आस्क योर क्वेश्चन सर. अनम्यूट.
मैंने मेरे यहाँ से दे दी परमिशन.
If you have any question, please raise your hands.
सलीम अहमद. Salim Ahmed.
Salim Ahmed, please ask your question.
Ahmed Abulgar.
अनम्यूट नहीं है वो सर, सलीम अहमद.
मेरे
अहमद अब्दुलकर.
Okay.
अहमद.
हाँ, yes,
Hello,
please.
sir.
Yes.
Are you with
Yes,
me?
you are audible. Ask the question.
Good afternoon to you all. My name is Ahmad Abubakar Suleiman from Nigeria. I'm very happy to attend this first webinar. I'm very grateful and for the speaker. She really do justice to the topic because she elaborated all sampling statistics. My few questions are, I have just two questions, one question and one observation. The first observation, I wanted to make a reference to the slide. To address to ask my question, but I can please ensure to make a slide number so that we can easily make a reference to where we want to ask the questions.
Okay.
And number two
Okay.
is
Which slide do you want to go? Excuse me. Which slide would you like me to go to?
Slide number 2.
Yeah, like the slide you are referring to p-value.
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 Yeah.
Okay, which is that slide which you want to know? Where we have calculated.
There are two or more slides where p-value is there.
So we had various p-values
here,
in the slide. So I cannot really make a reference to the slide. But my general question is about the p-value.
Excuse me, is this the slide that you want to see? Is this the slide?
Not this one. No, this one.
Next one.
So it will take time.
See what I'll do.
To save time.
This one.
To save our time, ma.
Yeah.
So sometimes we do reject hypothesis because after calculating the t statistics, to reject or accept hypothesis, we sometimes use either t value, z value, or any of the tables. So what is the exactly difference between p value we get from the p value and the table?
Yeah,
the table value we get.
Sure, I got your question.
Thank you very. I really enjoy your class.
Thank you so much.
Session. No, I like it. I want.
Yeah.
I was a master student in statistics from Sharda University. I'm now currently in Nigeria. So I hope next time I will join you to do my PhD. Thank you so
much. Here, let me answer your question. The difference is actually there are two approaches. One is the critical region approach, which you are talking about. And the other is the p-value approach, which we are using nowadays because most of the softwares are directly giving us the p-value. Earlier, we did not have softwares, so we used to use the book tables, and there we had only values for certain probabilities. So we selected 0.01 or 0.05, and can you see my arrow here? Supposing you find that for 0.05, the critical value is, for example, in the normal distribution. For 5% level of significance, the value is 1.96. So my critical region would be from 1.96 here onwards. That 1.96 I got from the book. Now, that was earlier, in fact, when I was a student. Now, because there are a lot of softwares, if I have the value 2.37, 3.213, I can find the probability directly from the software. So this is the new approach. That is why I took this approach. Otherwise, all you do is you subdivide your entire sampling distribution, the range of sampling distribution, into two parts. It's something like you are a professor, right? So it's something like you have the failing marks and passing marks for your students. Below 50% means fail, 50% or above means pass. It's something like this. So you create a critical region using those table values, T value, Z value, F value, which you've been doing. And then you have the critical region. If the value lies in the critical region, you reject the null hypothesis. It's one and the same thing. It's not different, except that earlier we did not have this facility of finding the p-value for everything. So there we said the p-value is less than 0.01 if you found the if you found from your tables the critical region corresponding to 1% level. If you found it corresponding to 5% level, you said that you reject at 5% level. But now because of the actual, because we can find the actual p-value, we use this new approach. Both the approaches are one and the same. There's no difference except that you have more flexibility now. You can say exactly the probability. Like here, the probability was coming to be 0.000088. So you can say the probability is so low, not just less than 0.01. Have I answered your question? Could I satisfy you?
Yes, ma. Thank you very much.
Okay, welcome.
So if still we are using computer, so therefore when our sample is large or small, the software will not take care of the large value or small value, because even if it is a small value, if you put it in Z, it will still give you a probability value. So one of the conditions you said, to use t-table, the sample size should be small. So sometimes you may see you use small sample and still it can be workable with Z statistics.
Because that's because your t-table goes only up to 30. Beyond 30, you can directly use normal. So t is approximated by normal beyond 30. That is why the table of t does not give you value beyond 30. If you use t for 30, you get the same value as Z. Okay, so you don't need to worry there. When when n is small, you should not use normal. When n is large, t and normal become one and the same. Okay. So for large sample, you don't need to worry. Okay.
Okay. Thank you.
Okay. Another person.
Dr.
Chanchal Jain.
Dr. Priya Mehta is there.
Dr. Chanchal Jain.
Chanchal Jain. Dr. Priya Mehta. Sir, please unmute कीजिए.
Hello, ma'am. Banerjee, ma'am, can you hear me?
I can hear.
Sure. Yeah. Good afternoon, ma'am, first of all. And I really appreciate the way you have explained the things to us. And my question is, ma'am, is every time we go or we try to reject null hypothesis?
Yeah, I didn't catch your question. No, we don't try to remove, we don't try to reject the null hypothesis. We hope that it will be rejected so that our alternative will be accepted. We cannot reject. Hello?
Yes, ma'am, I can hear you.
Yeah, can you hear me?
Yes, yes, ma'am.
Yeah, I didn't really catch your question. I thought you said every time we try to reject the null hypothesis, and then beyond that, what? We are not trying to reject the null hypothesis. मेरी आवाज नहीं आ रही?
Hello. Hello.
Yeah. I'm not getting. Just 1 second.
Unmute.
Unmute
हो गई है.
Okay. No, mine is
next,
unmuted.
sir.
Rashmi, mine is unmuted.
Dr. Priya Mehta.
हाँ.
Dr.
Priya Mehta. Unmute कीजिए सर उसको.
हाँ, मैंने कर दिया.
सर अनम्यूट नहीं किया है उन्हें, इसलिए वो नहीं पूछ पा रही है.
मेरी तरफ से मैंने कर दिया, उनको खुद को भी करना है
क्या? जी. डॉक्टर प्रिया मेहता.
उनकी आवाज आ रही थी थोड़ी देर पहले तो.
हाँ, आशीष कुमार साहू.
हाँ, आशीष कुमार साहू. आशीष कुमार साहू. ओके
मैडम, अपन जो भी पार्टिसिपेंट क्वेश्चन है वो अपन ये ऑफिशियल ईमेल आईडी पे अपन मंगवा लेते हैं. ठीक, बोल दीजिए.
So please mail your questions in our official mail ID. It's not possible to take all the questions because of shortage of time. Sir,
I'm typing
my. मैम कंटिन्यू करूँ मैं?
हाँ.
जी. Okay, so due to lack of time, we are ending the question answer session. So if you are having any doubt, you can mail us. We will answer you as soon as possible. Okay. So now I invite my colleague, Doctor.
I've written, just one sec, I've written my mail ID on my official web, on this slide. And they can see this is bans_1@rediffmail.com. So anybody who wants to share or who wants to ask any questions, they can ask me. Most welcome.
So,
all right.
Okay.
So
Thank you,
I
ma'am.
hope the
You can note
participants.
down the email ID, which is
This is my
on
email
the
ID.
screen.
They can note it down, and they can write to me also directly. If they write to me through you, fine. Otherwise, they can also write to me at my mail ID. Of course,
Okay,
with
ma'am.
reference to the conference. Okay. Please refer to the webinar because otherwise it will go to the go to spam.
Okay, thank you, ma'am.
This is my mail ID.
Thank you, madam.
Okay. Thank you,
Okay.
ma'am.
Thank you so
Thank
much
you
to
so
the
much, ma'am.
organizers and the participants. I hope it was useful. I'd like to get your feedbacks, and all the best to all of you for your research.
Thank you, ma'am.
Thank you so much, ma'am, for your
Welcome.
commendable talks on the subject. It was very useful. Now, I would like to invite Surbi Ghodki, ma'am, for vote of thanks.
Thank you so much, Divya ma'am. Am I audible?
Yes.
Yes.
Yes, yes.
Okay. Thank you so much, ma'am. Now proceeding forward, honorable principal sir, respected professors, and all the participants. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, Surbhi Godki, on behalf of Department of Statistics, Government Holkar Science College, Indore, first of all, extend a very hearty vote of thanks to the eminent speaker, Dr. Snigdha Banerjee, who has spared time from her busy schedule to grace the webinar. I also extend thanks to all the participants from worldwide to take interestingly part in this webinar. My talk would be incomplete unless I place on record my deep felt respect and gratitude to our principal sir for inspiring, motivating, and leading us all the time, and also for giving us a platform to show our worth. Sir, your eminent presence has indeed made this webinar a memorable one, and we unitedly thank you for your concern over the college and the gracious presence. I would indeed be failing in my duty if I do not express our gratitude to all the heads and professors of Holkar Science College and of different colleges from variant states for the cooperation in this webinar to make it a grand success. I also want to thank to the program coordinator, Dr. Netram Kaurav sir, head of electronics department, and Professor Shivlal Mewada sir, for head of computer science department, for their technical support and helps to build positive relation within the team and external parties. Thank you, sir, for keeping all the members of the team up to date with relevant information and communicate with the team and for scheduling and organizing the webinar. I must not forget to thanks to the convener, Professor Mangala Choragde ma'am, Head of Statistics Department, and to the organizing secretary, Dr. Rashmi Awad ma'am, for supporting and guiding us in all the work, and for their continuous effort to make this webinar a successful one. Thank you so much, ma'am. Now, I just want to make some announcements. The next session will be conducted tomorrow by 9:30 a.m. So please join the session by 9 a.m. Thank you, everyone.
Thank you, Surbi.
Thank you so much, ma'am.
Madam, Choragde madam.
ठीक है मैडम, मीटिंग
हाँ,
मीटिंग
हाँ,
ठीक है,
एंड करें. हाँ.
हो गया
Thank
ना?
you, madam. Snigdha madam, thank you.
Hello.
Hello.
Anyway, I am closing meeting
हाँ.
to prepare for the next meeting.
जी sir.
It is
ठीक है.
end for all.
Okay.
Thank you.